Hi everyone, welcome to today's homework help, lesson 8. Let's get started. Use digits in a comparison symbol to write 1 and 3/4 is greater than 1 and 3/5. So obviously we're going to be using our comparison symbols, greater than, less than, or equal to. And really what you have is 1 and 3/4 is greater than, and then the other number which is 1 and 3/5. So these are both mixed numbers. Keep in mind that you're going to have a whole number, numerator, and then denominator. Use the appropriate comparison symbol, and then whole number, numerator, and denominator. Now, even though 3/4 and 3/5 have the same numerator, the denominators being different means that we need to really visualize which one of these actually has more, because they both start with 1 as well. So it's 1 and. So the comparison is really between the fractions. So 3/4 means we have 3 of these pieces, and 3/5 means we have 3 of these pieces. But if you notice, 3/5 actually has less space taken up than the 3/4. So it's going to be a smaller value than the 1 and 3/4. So when you write it out, make sure you select the correct comparison symbol. For number 3, we are skipping number 2. So number 3, what is the quotient when the product of 20 and 20 is divided by the sum of 10 and 10? So again, find the product of 20 and 20 first, and whatever your product is, we're going to divide by 10 and 10, which I will give you is 20. And we're going to divide the product of 20 times 20. Once you have that product, divided by 20 to find your quotient. For number 4, we want to list the single-digit divisors of 1,680. So we use our divisibility rules. We know that it can be divided by 1. Since it ends in an even number, it can also be divided by 2. And since it ends in a 0, we know that 5 is also one of the divisible factors. So to find the rest, use your divisibility rules to test and see which ones are factors of 1,680. And again, we're only going for single digit numbers, which are all the numbers between 1 and 9. For number 5, we want to write down the mixed number represented by this point A on the line. So we know that it's going to be between 3 and 4, which means that the whole number should be 3. And then again, your denominator is the amount of spaces that you have, or fractional parts that make a whole, from 3 all the way to 4. That's going to be your denominator. Your numerator is going to be how many spaces or fractional parts are filled up between the whole number 3 and the graphed point, which is A. So that's going to be your numerator. For number 6, we want to use our comparison symbols greater than, less than, or equal to. And we have 3 plus 2 compared to 2 plus 3. And after you've compared them, you want to know what property we're using. So here, all we did was change the order of the numbers. So changing the order of the numbers gives us a very specific property. Remember that our properties are associative, commutative, and identity for addition. For number 7, we want to write this number using words. And in order to do that, we're going to really need to space out the zeros. So there's 3 zeros, 1, 2, 3. There's another 3 zeros, and then 1, 2, 3, and then there's another 3 spaces. So we need to find the place value of the number that has 9 digits. So we know for sure that we're going to be using the word billion because we have those 9 digits. And then from there, it's just a matter of writing out the place values for the other numbers. 8a is asking us to find the fraction of the circle that's shaded and the fraction that's not shaded. So both of these are going to be out of the same denominator because they come from the same circle. In this instance, we have 8 fractional parts for the circle. So then the percent that is, or the amount shaded would be your numerator. And then for b, the amount that is not shaded would be your numerator there. Both of these fractions, when you add them together, should actually be equal to 8 over 8, or 1 whole. Now 9's a little bit different because we want percentages of so we want the shade percentage and the not shaded percentage. So for the shaded percentage, if we take that this is 100%, the entire thing is 100%, then we have to split up that 100% evenly into 1, 2, 3, 4, 5 different parts. So if we do that evenly, that would be 100 divided by 5, which means that every bar represents 20%. So then the number of bars that are shaded would be your percentage of shade, and the sum of the ones that are not shaded would be your not shaded percentage. For number 10, what is the name of the part of a fraction that indicates the number of equal parts in the whole? So in a fraction, equal parts in the whole just basically means that if we have any amount, how many parts make the whole, or how many parts are equivalent to a whole. In this case, one circle is equivalent to 4 out of 4 parts. So all we want to know is the name of the number that tells you how many parts you need to make a whole. For number 11, we're going to use inverse operations. A minus $4.70 equals $2.35. We are subtracting, and the inverse of that is addition. Since we are adding decimal numbers, we want to make sure that our decimals, or our Herculean planets, are aligned. And then from there, you just simply find the sum. And you will find the dollar value for A. Now for B, or 12, we have B plus $25.48 equals $60. Again, inverse operations are going to come into play here because we want the opposite of addition, which is subtraction. And even though we're subtracting, we're still going to line up our decimal points so that we are able to calculate the correct amount when somebody spends $25.48 from a $60 that they originally had, or subtracting, not adding. And again, make sure that your decimals are lined up and that you regroup as necessary. And continue regrouping when you need to. For number 13, we have 8 times C equals $60. A reminder that when a variable and a number are next to each other just like this, we have multiplication. So our inverse operation would be to divide both sides by the coefficient, which is 8. Those will cancel out. So C will be the equivalent in dollars of 60 divided by 8. For number 14, you'll notice that the subtrahend is actually the variable. So we have 10,000 minus D equals 5,420. Since the subtrahend is the variable, this is when we do our little trick where we just switch places, and then it's going to be 10,000 subtract 5,420 to find the value of D. For number 15, we will be using inverse operations. E divided by 15 equals 15. So since the denominator is 15, we want to multiply, which will cancel these amounts out, and then we're going to multiply this by 15, and that will give you your correct response. Now 16 is a little bit different. We're not going to use inverse operations here because we are going to use, since the divisor is the variable, we're just going to switch these around. So it's going to be 196 divided by 14 equals F. And then from there, you would just compute and find the quotient. 17. We want to give a reason for each of the first 2 steps taken to solve the equation. So what we have here is 9 plus the parentheses n plus 8 equals 20. So that's what's given to us. And the first thing that was done is we changed the order inside the parentheses, 8 plus n. So the property for when we changed the order is the commutative property. And then we regrouped it. So we put all the numbers inside the parentheses, 9 plus 8. So when we changed what's inside the brackets, even though the order stays the same, that's the associative property for B. You'll see that the solution ended up being 3 because they used commutative property and then inverse operations. So for 18, we're just multiplying. And so you could do this one of 2 ways. You could do this the standard algorithm where you multiply 0 times 0, 0 times 0, 0 times 4, etc. Or you could just, similar to the box method, 5 times 4 is just 20. and then you're going to add every single zero that was given to you. And you can only do this when both numbers end in a zero. Or if one number ends in a zero and the other one just has one single digit, you can also do that. But if this had been 55, for example, then you couldn't just do it from here. You'd have to set up your box and solve that way. For number 19, and this is something that I just mentioned, 79 cents times 30. First and foremost, your answer should be in dollars because this is going to be more than a dollar. But second of all, you could, again, use that box method or the standard algorithm, which is being shown to you right there. Here, you would just multiply these and add. So that's going to be 270. And this is going to be 2100. And then when you add them, just keep in mind that since it is in dollars, you should move the decimal twice to the left. So that your number is being represented in dollars and not cents. For number 20, it's just a simple addition problem. So we have 5 plus 1 is 6, 6 plus 7 is 13. You carry the 1 over. 8 plus 2 is 10, 11, and then 14. And then you just continue adding until you are able to complete the computation. 21, again, a simple division problem. 50 goes into 6,000. We can actually make this a little bit simpler, but we're not going to do that right now. 50 goes into 60 once. So we divide, multiply, write better fives perhaps, subtract, find the difference, bring down zeros. And then we just continue to divide, multiply, subtract, and then bring down until there's nothing left. For 22, we just want to multiply it any way we can. I would probably do 10 times 5 first, because that gives me 20 times 50. And then from there, I can use my mental math steps with numbers that end in 0 to just do 5 times 2, and then add the 2 zeros at the end. For 23, a long division problem. It is in dollars, so our answer should be in dollars. But we're going to have 18 going into $27. And so remember that just like with the adding, we want to place the decimal above itself and then divide. So again, we'd place the decimal above itself, and then you just would continue with your log division. 18 goes into 27 once, multiply, subtract, and then bring down. And then repeat the process, divide, multiply, subtract, bring down. For 24, we are just dividing 6 into 3,456. 6 is the divisor, 3,456 is the dividend, and then you just find the quotient. Again, divide, multiply, subtract, and bring down. And then you complete the computation. 25, we are evaluating t minus v and v minus t. For t minus v, it's just going to be 1,000 minus 11, which we can compute. And for b, it's actually v minus t. So the fact of the matter is that since it's 11 minus 1,000, since the minuend is smaller than the subtrahend, the answer is actually going to be negative for b. But as we mentioned earlier in the school year, you still subtract like you normally would, where the big number has to go on top. So your answer should not be 1,011. It should be less than 1,011 for sure. And then when you subtract, just keep in mind that for B, your answer is going to be negative because the minuend is bigger than the subtrahend. For 26a, we're being asked to find the 10th term of the sequence. And to do that, all you have to do is evaluate for n being 10. So you're going to do 3 times 10 first, and then you're going to subtract 1. For B, what pattern do you recognize in the sequence? So how do you get from 2 to 5? How do you get from 5 to 8? How do you get from 8 to 11? And that would be the pattern. For 27, we're being asked to compare the results of these. So we're going to add 886 and 119 first, and then subtract that from 416 for the left. But on the right, we're going to subtract 416 and 86, and then add 119. And then use the proper comparison symbols greater than, less than, or equal to. For 28, we are being asked to name an acute, obtuse, and right angles. So the right angles, the acute angle would just be this angle right here because it's less than 90 degrees. Now to name it, you'll notice that you have to start the starting point C and then make your way over to B and then move up to A. So the name of it would be C, B, A, or A, B, C. Again, for angles, as long as wherever the vertex is, where the two rays meet, as long as that corner is in the middle of the name, the other two doesn't matter what the order is. Now, for obtuse, we have this angle here, which has A as the vertex, and then you would just fill in around it from where you started and where you went. So that has to be in the middle. You see the D that is on the left, making 1 point. But then if you were to continue down, you'll notice that the B here is actually, instead of being in the middle, it helps form that obtuse angle. Now for the right angles, we actually have two right angles, and you want to make sure that they're both represented. 1 and then 2, and that you use the proper names. In this instance, D will be the letter in the middle, and in this instance, it will be C. Now, for 29, we're being asked to name a segment that's parallel to DA. So this is segment DA. We want a segment that's parallel to it. So a line that's not connected to it. So we have CD, which is connected, AB, which is connected, but you see the line that's across is not connected, and if you extend them out, they're not going to ever intersect. So those would be parallel lines. Now, perpendicular to DA means that we're going to have a right angle, which you'll notice is actually DC. And since it's perpendicular, you'll also notice that they have a corner in common, which is D. Now for 30, referring to this figure, what's the difference between the notations QR and QR? So one of them has a line over it, and the other one does not. And the difference in notations is that QR specifically, with the line over it, tells you that it's a segment. Where QR without it just tells you how long it is. QR, anything with the line over it, is going to be a segment. So it's going to be telling you about what it's composed of or what it is. Where anything without the line is just going to be telling you how long it is. So QR is 5 inches long. Where QR with the line over it tells you segment QR. So this has been your homework help for today. Today is the first day of September, and there are some pretty famous songs about September. So your extra credit for today will be to name a song that has the word September in the title. It can be any song, as long as it has the word September in the title, and you have to give me the artist as well. So there are plenty of famous songs that have the word September in the title. So make sure that you also list the artist. And then we'll go through and maybe jam out to a couple during our dance break tomorrow. So that is homework help for today, lesson 8. Hope you have a great day, and we'll see you tomorrow.